All right, so today, class, I want to show you how to integrate over a surface. So we're actually, by this integration, we're actually finding volume underneath a surface. So what if I give you a surface like this? F of x of xy equals 1 plus x plus 1 squared plus 4y squared. And I want to know what's the volume underneath this surface for x between 0 and 3 and for y between 0 and 2. This one's pretty easy to set up. This is just going to be a double integral, so we actually do a double integral like so. For x, it goes from 0 to 3, and then from y, it goes from 0 to 2. The order of this doesn't really matter, just that we know that this one, by the way, is the y, and this one is the x. So the y is on the inside, the x is on the outside. If you switch it, it's going to, if you make the y on the outside and the x on the inside, then that changes your dy dx in the end. The function goes on the inside, 1 plus x plus 1 squared plus 4y squared. Now, we then, since y is first, we want dy on the inside. This way we're going to integrate with respect to y first, but then we're going to integrate with respect to x. So that's why, so if I have the y here, now if I switch this x and y, I would need to switch this dy dx. It doesn't matter what order, but you do have to be consistent, right? So if your y is on the inside, your dy needs to be on the inside. If your x is on the outside, your dx needs to be on the outside. Okay, now, going through this, I'm first going to integrate with respect to y. So integrating this thing with respect to y means, well, what's the integral of 1? Well, the integral of 1 would just be y. The integral of x plus 1 squared, well, I'm not integrating with respect to x, so I just treat it like it's a constant. So if it was a constant, the integral of it would just simply be x plus 1 squared times y. The integral of this, obviously, is 4y cubed over 3. Now, I want to do this from 0 to 2. Then we have the integral from 0 to 3 dx. So that goes on the outside still, because we haven't integrated it with respect to x yet. So plugging in the 2, so again, I'm going to do my integral from 0 to 3. Okay, so when I plug in the 2, I get 2 plus x plus 1 squared times 2 plus 4 times 2 cubed over 3, like so. But that's just the first. Now I need to subtract when y is 0. Luckily, when y is 0, this whole thing goes to 0. dx. So that's easy. Okay, let's clean this up a little bit so that we have an easier time when we integrate with respect to x. This is still going to be 2. This is going to be, well, if you want to multiply this out, you can, but might as well not. Plus 2 x plus 1 squared plus, this looks like it's going to be 8 times 4, which is 32. So this is 32 thirds dx. Okay. By the way, I get to actually rewrite this again. In thirds, this is 6. So I'm going to actually go up to 38 thirds plus 2 x plus 1 squared dx. Okay. Now, integrating this from 0 to 3. Well, again, I'm integrating with respect to x, so this is just simply 38 thirds times x. This integral, well, we raise the power. This is basically a u substitution in a sense, right? I'm taking this as u, but then du is just simply dx. So this thing I'm going to raise to the third power and divide by 3. So this is going to be 2 x plus 1 cubed divided by 3. Now I want to do this from 0 to 3, and so we put our 0 and 3 there. When I plug in 3, I'm going to get 38 thirds times 3 plus 2, 3 plus 1 cubed over 3 minus 0, because when I plug in 0 here, this becomes 0. Plus, plugging in 0 here, though, gives me 2 times 0 plus 1 over 3. Oh, that's cubed. There you go. So that's it. Now, obviously, we get to 38 plus, what is this? This is going to be 4 cubed. 4 cubed is 64, so we have 64 times 2, which is 128 thirds. Minus, this is just 0. This is 2 thirds. There you go. So minus 2 thirds gives me 126 thirds here, which is 42, right? So really we have 38 plus 42, which is 80. So the volume on the bottom, so the volume here, under this, between these things, is 80. So obviously this thing takes quite a while, but the thing is it's not that, challenging. It's just more tedious than anything else. Okay, let's do another one. So this one's a little more interesting because instead of just having a square underneath the surface and integrating over that square, right? So this one we had the square. We had just a rectangle from 0 to 3, and like it had a base of 3 and a height of 2, and we just integrated the surface on that over that square, right? So like if I were to graph the square would simply be, here's my x goes from 0 to 3, and my y goes up to 2, and I'm integrating the surface over this square, right? It kind of comes up towards you. This surface comes up towards you over the square, and we find the volume. Okay, this one, what is the volume of the function if the base is in fact x squared, where y or g of x equals x squared or y equals x squared? So basically what I'm doing here is I'm saying, okay, look, I want the base being this area underneath x squared, right? So in other words, so that's kind of what I'm looking for. Now, well, I have to integrate over that surface. So what is this surface actually defined by? Well, it's defined by x. So if it's defined by x, it's better to integrate x second. So where does x go from and to? Well, x starts here, right? The corner goes all the way over here. So the x actually starts at 0 and goes out to 1, right? What about the y? Well, the y starts down here at 0, but instead of going all the way up to y, because that would just make a square, or all the way up to 1, because that would just make a square, we're not going to go all the way to 1. We're just going to go up to x squared. So we are going to go from 0 to x squared. So you can actually integrate to one of the variables and then integrate that variable specifically. So continuing to set this up, we're going to integrate with y first and then x, right? This is an indication of what y is. By the way, another way to set this up would be to say, okay, let's think about, let's define this instead of doing, so this is my y, this is my x. So instead of doing that, let's switch them. Let's do the y, but the x as well. Well, if we're doing the x first, that means we have to do it in terms of y. Well, the x basically goes, since we're doing a volume, right? It actually is going to go from the square root of y, right? Square root of y up to 1. And then, so it's going to go from here to here. And then y is going to go from 0 to 1. X plus 2y. In this case now, dx dy. So these two things are actually would actually be the same. I'm going to do this one, but this one would actually result in the exact same answer. Okay, so let's go back to this one. All right, integrating this with respect to y is fairly simple. With respect to y, we're going to get xy plus y squared from 0 to x squared. And then on the outside, we're integrating from 0 to 1 dx. Okay, so now we're going to plug in x squared wherever we see the y. So we're actually going to get x times x squared plus x squared squared minus x times 0 plus 0 squared dx from 0 to 1. Obviously, this is all just 0, so that goes away. This right here becomes x cubed plus x to the 4th. And I'm integrating this from 0 to 1. Whoops, sorry about that. Off the page. But, so, right, this becomes x cubed, and this becomes x to the 4th. That goes away, and I'm integrating from 0 to 1. So this ends up being fairly simple, because the integral here is x to the 4th over 4, plus x to the 5th over 5, from 0 to 1. The 0 when you plug it in goes away. The 1 when you plug it in becomes 1/4 plus 1/5. You're going to have to go up to 20 to actually solve this. And so you're going to get 5 over 20 plus 4 over 20, which is 9 over 20. So the volume underneath this curve, actually it's not even a curve, it's actually just like it's a flat surface. This one would be just a flat surface. But the area underneath this flat surface is 9/20. I want to do one more. Okay, this one's a tough one. All right, so find the volume below z equals 1 minus y. That's generally, if it's z equals or if it has z involved in it, that's usually the function we're going to be integrating. I want it to be above -1 to 1 on the x. So here's -1, here's 1. So I want it in between here on the x. And the y, I want in between 0. So here's 0, obviously. And 1 minus x squared. Well, 1 minus x squared is this. So I'm going to want this surface right here having this height. So I want this surface having this height. So how would I find the volume of this surface? This surface, right? The surface doing that, but along this whole surface, it has, the height is defined by 1 minus y. Okay, so, what would be the volume there? Well, I would suggest, okay, so let's see. I would suggest the easiest one is to say, well, let's go with the y being this, and then we'll say, well, once we define the y as this, we can define the x as just going from -1 to 1. That seems pretty easy. So the y is going to go from 0 to 1 minus x squared, and the x needs to go from -1 to 1. Do I put that integral on the outside or the inside? Well, the one on the outside needs to only have numbers, right? Notice this example. Notice how the one on the outside is the 0 to 1. The one on the outside is the 0 to 1. So no matter what, you always want the integral on the outside to never have any variables in it. So the integral on the outside, if it has a variable in it, you're going to be wrong because you're going to be left with variables and not an answer. So this has a variable. It needs to be on the inside. The one that's on the outside, right here, needs to be in terms of, so this is the y, right? So this one needs to be the x, -1 to 1. And what's the function? 1 minus y. dy dx, right? Oops, x. That's the y, that's the x, so it needs to go dy dx. All right, ready to integrate. First, we're going to integrate with respect to y, which is y minus y squared over 2. We're going to go from 0 to 1 minus x squared. And then from here, we have our integral from -1 to 1 dx. -1 to 1. So when I plug in, I'm going to get 1 minus x squared minus 1 minus x squared over 2. Then I have to plug in, so that's the first one, minus plugging in 0, but if I plug in 0, I'm just going to get 0 and 0, so minus 0 dx. All right. So this now gives us -1 to 1, 1 minus x squared. I'm actually just going to multiply this whole thing out. I think it is going to be easier since I can't really use a u substitution here. So multiplying it out might actually be my best bet. So we're going to get a 1, but it's going to be minus. So it's actually going to be minus 1/2. Now here I'm going to get a negative 2x squared. Negative 2x squared, but since it's that, it's actually plus 2x squared over 2. Right? That's me multiplying this out. Then I'm going to get a positive x to the 4th. But a positive x to the 4th, now it's going to be negative and divided by 2. So negative x to the 4th divided by 2. And now I'm going to have my dx on the outside. So I'm going to actually, simplify this a little bit. Negative 1 to 1. My constants are 1 minus 1/2. Well, let's start at the top. Let's start with the x to the 4th. This is the only x to the 4th, so negative x to the 4th over 2. X squared, I get 1x squared here, and a negative x squared there. So that actually all goes away. And this becomes just simply a positive 1/2. And now I'm ready to integrate. So this is going to become negative x to the 5th over 10. And this is going to become x over 2 when I integrate that. I'm going to go from negative 1 to 1. So when I do that, when I plug in 1, I'm going to get negative 1/10 plus 1/2 minus, now plug in the negatives. When I plug in negative, I'm going to get a positive 1/10. And when I plug in negative 1 here, I'm going to also get a minus 1/2. So negative 1/10 plus 1/2 minus 1/10 plus 1/2. Well, that's 1 right there. So this is 1 minus 1/5. In other words, 4/5. And that is how we integrate over a multivariable function. Yeah. One little extra thing, so for example, remember sort of the average value. So if I wanted the value over this thing, the average value over this surface, if it's this volume, you would take the volume, right? You would take the volume and you would divide it by the area of the bottom. Last time we would take, for the average, we would take the area and divide it by the length of the interval. Sorry. We would take the area divided by the length of the interval. Here we're going to take the volume and divide it by the area. So we would actually have to figure out what the area is, but the area would be pretty simple, right? We would do the area here is going to be the integral of 1 minus x squared, and we would just go from negative 1 to 1 dx. So x minus x cubed over 3, right? From negative 1 to 1, plugging in the 1 gives me 1 minus 1/3. Then I would plug in the negatives, but notice really I'm just going to get double. So in fact, it's just going to be 2/3, which ends up being 4/3. So 4/3 would be, so the average would be 4/5 divided by 4/3, which is 4/5 times 3/4, or 3/5. That would be the average. So the total volume is this. The average over the area is 3/5. So that's kind of a little side note. But anyway, the homework is posted, so try those out. I got 3 of them on there. We can meet over the next few days to see how people did. But that's your final homework. I think that's good enough. So turn that in for some credit, and that'll be great. Anyway, hope you have a good one, and try these out. They're kind of fun. See ya.